This lime requirement test is a protocol to determine the lime requirement of a batch of substrate using a pH titration curve. Our objective is to determine how much lime needs to be incorporated into substrate for a particular liming material in a specific batch of substrate in order to achieve a given target pH. The principle behind this protocol is to develop a titration curve using calcium hydroxide. If we look at this graph below, we can see that as we add more and more calcium carbonate to a growing medium, we get an increasing pH in a more or less linear phase, followed by a diminishing returns or plateau phase. As pH increases in the substrate, the lime reaction rate decreases. If we just focus on that linear phase of that graph, and we have some points along that curve, then we can fit a curve to our data where we use the very simple straight line equation pH equals m plus n times b. And in this equation, m represents the intersect with the y-axis, or the non-lined substrate pH. N is the gradient or buffering capacity of that substrate batch, and b is the grams per liter of applied limestone. So we can use that same equation to calculate how much lime, or B, we need for any particular pH that's in our target range based on a pH titration curve. The overall procedures in this protocol are really quite straightforward. We take some substrate where we've added everything except for the liming material, including the nutrient charge and the wetting agent. We develop a pH titration curve using calcium hydroxide, which is very reactive and has a broader linear pH range than a carbonate lime source. We enter the data into our spreadsheet called the LimeR lime requirement model to calculate the lime rate that we need for a given target pH. In order to develop some data points along that graph, we need to measure out 0, 1, 2, or 4 grams of calcium hydroxide per liter of substrate. The calcium hydroxide is mixed into a growing medium sample. We add distilled water to bring it near to container capacity, so there is no free water, but if you squeeze this growing medium, you can get a water sample that can be tested for pH. We put the substrate in an open plastic bag at room temperature for at least 3 days, and then we measure the substrate pH by squeezing the solutions out of the plastic bag. Here you can see that we're putting our pH sensor directly into our bag and measuring in the slurry. Those data are entered into the spreadsheet, which plots the average pH at each lime rate compared with the corresponding amount of calcium hydroxide, expressed as calcium carbonate equivalents. The spreadsheet is then used to predict the lime rate required for that particular batch of substrate and liming source. This is what the program looks like. The gray cells are where you enter data, and some of the output is shown on the graphs on the right hand side. So you enter in the grams of calcium hydroxide that are added. In this case we've added 1, 2, 3 or 0 grams to our sample. We've measured the pH after 3 days, and we've chosen a couple of our data points that are in the range that we're interested in, close to our target pH. In this case, our target pH is 6, which is a typical level for a soilless growing medium. we enter some information about the limestone that we plan to use in our blended growing medium. In this case, we've got an effective calcium carbonate equivalency of 0.82, which is discussed in one of our other protocols, the type of lime being carbonate or hydrated source, and then a descriptor for that limestone. Here's one of the outputs from our system. It calculates, for example, the pounds of lime per cubic yard required to achieve the target pH of 6 that we entered into the spreadsheet. And so there, on the lower right hand side, we've got a graph that shows increasing kilograms per cubic meter of limestone and the substrate pH we would expect with this liming source. We'd like to thank the students and staff at the University of Florida, our colleagues Bill Argo at Blackmore Company, and Paul Nelson and his team at North Carolina State University, who've done a lot of research work on lime. Funding was provided by the American Floral Endowment and our partners in the Young Plant Research Center. The Young Plant Research Center is a collaboration of universities and leading media and fertilizer companies, and also leading growers, especially those that specialize in young plant production.